ingredients. In this problem, we want to identify the formula weight for an unknown gas from measurements of its density, its temperature, and its pressure. So the first thing we need to recognize is since we're dealing with a gas, we need an equation of state for a gas. And in this class, we're going to treat this as an ideal gas. And we're going to use the ideal gas law, PV equals nRT, pressure, volume, the number of moles, the ideal gas constant, and the temperature. Now, we're given data on density, so we're also going to need an equation with density. And we know that the density of a compound is equal to the ratio of its mass over its volume. And in our case, we were given the units of grams per liter. Now, we want the formula weight, so we also need an equation that has the formula weight on a compound. And the formula weight, and I'm going to use FW for formula weight, is the molar mass of a compound, or the grams per mole, the mass per mole. We use N for mole. Now, most of us will start with the ideal gas law because this is the gas chapter. But let's think about this for a second. We're solving for formula weight. This is what we're after. So let's start with the formula weight. So I can say that the formula weight is equal to the mass per mole, okay? Now, am I given data on the mass or the mole? No, I'm not. And incidentally, I'm going to write this as a small m here. So I could say that the mass is equal to the density times the volume and substitute this in. So over here, I could say the mass is equal to dV. So if I substitute this into here, I now have the formula weight is equal to the density times the volume over the number of moles, okay? But I've got pressure and temperature data, not the number of moles, so I need to rewrite the number of moles from this. So from the ideal gas law, I can say that the number of moles is equal to PV over RT. So now I can substitute this into here, and I have the density, volume, and now in the denominator, I have PV, and then in the denominator of the denominator, which goes up to the numerator, I have RT, okay? So I substituted in PV over RT for here. Now my volumes cancel, and I have my formula. The formula weight is equal to the density times RT over P. Now I start plugging these in. My density is 4.08 grams per liter, I believe. R is 0.08206 liters atmospheres per mole Kelvin. Now my T was 88 degrees, but this is in Celsius. Remember, we always have to have the temperature in Kelvin when we're using the ideal gas constant. So I add 273.15. And now I need to divide this by the pressure, which was given in the problem as 1.4 atmospheres. Okay, my atmospheres cancel, my liters cancel, my Kelvin, this was all Kelvin here, cancels, and I have grams per mole, and I bring out my calculator, and I come up with 86.4 grams per mole. Now, there are many ways that you can solve these problems. What's the advantage of this technique here is I have a series of equations, and I need an equation with what I'm solving for. So I simply started with that equation and then substituted the other ones in until I came up with my final solution. Okay, I hope that all makes sense, and good luck.